Hi everyone. So this is Unit 5, Lesson 1, Expanding and Factoring Polynomials. Just a quick note about this unit. So if you looked originally on Brightspace, we had a Unit 5 and Unit 6, but due to the timetable that we have for summer school, I've just combined them into one unit. So this is your quadratics unit as far as factoring and as far as solving equations goes. So essentially there are now two units under the quadratics topics, Unit 4 and Unit 5. Unit 6 has been removed, and that's just going to be trigonometry now. Okay, so Unit 5, I have only a couple lessons here. They're likely to be a little bit longer because we have a lot of material to go through. I'm not going to give you that many examples. What I'm going to do is give you links to more examples, but I am going to run you through at least one example for each thing that we're covering, just so you have that available to you that you can just look up on this handout, and just to make sure that I've given you some of my own commentary, because you're going to have to answer my questions on the exams and assessments. So I want to make sure that you have my spin on these questions, so that can help you with those aspects of the course. Okay, that's long enough. So learning goals. By the end of this lesson, you should be able to expand polynomial expressions by using the distributive property. So a bit of review from grade 9. And then we're going to work on factoring. So this is your factoring lesson, and we're only going to focus on 3 factoring techniques: common factoring, decomposition, and difference of squares. We'll talk more about why we're only covering 3 techniques as we go further down. Okay, multiplying polynomials. So that's going to go with our first learning goal. That's usually involving what we call expansion. So this uses the distributive property. So when you're multiplying polynomials, use the distributive property, collect like terms, and simplify. So those are your steps. So what I'm going to recommend when you do these problems is do them a step at a time. Take your time with them. There is a temptation to rush and to write messy. Please don't do that. Please take the time to write slowly. Take your time, because that's going to let you solve the question easier, right? If your writing's too messy, you might not see what you've done. If it's disorganized, it's hard to follow your thinking, not just for me, but even yourself when you're doing it. So take your time, do it properly, and you'll come out with the right answers. Okay, so what if we have an expression like this and we want to simplify it, meaning we want to make this have as few terms as possible, or kind of get rid of some of the numbers in here and make it simpler? Well, we can do that by expanding, and we expand by using the distributive property. So hopefully this is just all review. So what we're going to do is I'm going to take this 3 here and apply it to this bracket. Right, I only have to apply it to one bracket because that's how multiplication works, right? If we have 2 times 3 times 4, then the answer to this will be 2 times 3 is 6, 6 times 4 is 24, right? So this is 24. When you're solving this problem, you don't do 2 times 3 and 2 times 4. You just do 2 times 3, and then whatever that answer is, you do times 4. So we're going to do 3 times this bracket, and whatever that answer is, we're going to multiply by the last bracket. Also, you'll note that I can solve this by 4 times 3 times 2. So the order that doesn't matter. I'm just going to go left to right to keep it simple and try to make sure I'm not confused. Okay, so 3 times 2x is 6x, and then 3 times negative 3 is negative 9. So I've done that in one row just to keep it simple, right? I'm not trying to do too much at one time. Now we'll move on to the next row. And you can kind of help yourself out here if you want, because you'll notice that you have 2 terms here multiplied by 3 terms there. So when you do the full-on multiplication, you know that everything in here is multiplying everything in there. So you should end up with 6 numbers. So when you do this, you should tell yourself, okay, I need to have 6 numbers written down here. If I don't have 6, I've missed something. 6x times 5x, right? So 6 times 5 is 30, and x times x is x squared. So that's 30x squared, right? X times x is x squared, not 2x. 6x times 2xy, so that's going to be 6 times 2 is 12. X times x again is x squared, and the y just follows with it, so x squared y, so that's going to be 12x squared y. 6x times negative 4 is negative 24x. So now I've done everything to do with this 6. So I move on to the negative 9, and remember there is a negative there, so the negative goes with the 9. So negative 9 times 5x is negative 45x. negative 9 times 2xy is negative 18xy, and negative 9 times negative 4 is positive 36. Okay, so now what I'm going to do is I'll notice that these two terms are like terms, and they're already grouped together, so I can simplify those. Right, I have an x there and an x there. Those are my only two like terms. Right, you can't add an x to an xy. Right there, if you have an xy there, you can't add them. It's a different term, right? You can think of this about algebra tiles. If you want sort of apples and oranges, you can't add these two because they're different. You could multiply these two numbers, which we've done up here, but you can't add or subtract them. Same goes with this x squared y. So again, that's different from everything in here, including this 18xy. So the only thing we can do is just this part. So negative 24x minus 45x is negative 69x. So we've combined those two, and everything else just stays the same, and we're done. So there are a lot of variations on this, and I'm not going to go over all of them with you. There are more than I can probably even think of. Some of them you'll be able to figure out on your own if you just practice. If you follow the rules and go step by step, you should be hopefully able to do most of them. But there are a few more examples in this video if you need them. So please feel free to check it out. Okay, so that's all I want to say about expansion, distributing, and multiplying polynomials. What about factoring? So the first thing I want to do here is cover what is factoring, right? What does this whole thing mean? Why do we call this factoring? You've probably done factoring in elementary school where you have a number like 12 and you have to find the factors. So 3 and 4 are factors of 12. But 4 can be further factored, right? So we can say that 12 is equal to 3 times 4, but we can also factor 4 into 2. So we can get that as 3 times 2 times 2. So 12 fully factored will be 3 times 2 times 2. You could say 12 and 1 are factors, but that's what we call kind of like trivial. It's every number has itself and 1 as a factor. So 3 times 2 times 2 are the important ones to get to 12. But you might have chosen 6 and 2 as factors of 12, right? So 12 could equal 6 times 2, but then that 6 can be further broken down, and you get 12 is equal to 3 times 2 times 2. So when you break everything down into the lowest factors possible, then you're going to get the same answer here and here. The numbers might be in different order, right? Multiplication, the order doesn't matter. 3 times 2 is the same as 2 times 3, but your numbers will be the same, and you'll have the same number of them. So I have 1 3 and 2 2s, 1 3 and 2 2s. Okay, so basically when you're factoring polynomials, the same rules apply. So you can take this large term and break it into 3 things that are multiplied together, and that's factoring, right? So you're representing this as 3 numbers multiplied together. This looks a little confusing, but you can think of 2x minus 3 as one number, and 5x plus 2xy minus 4 as one number. So you can multiply these 3 together. So that breaks this apart. And so what you might notice when you're factoring is if it's a complicated question, there might be multiple techniques that you can use. And so your answer might look a little different from somebody else's, especially in the first couple of steps. But if you both do everything right and factor fully, you should get the same answer at the end, just like you do here, right? The 3 times 4 looks different from 6 times 2, but the end looks the same for both. So that's also true when you factor polynomials. All right, and just to make sure that you kind of recognize what's going on here, so this whole thing can be factored into this. I'm not going to cover how you actually factor this into that. That's quite complicated. You'll be able to do this when you get to grade 12. But for now, you know that this can factor to that because of what we've done up here, right? We know that when you expand this, you get that. So factoring is just the reverse of expansion, if you like. It's going from this to that. Okay, so when you expand, you multiply everything together and get your large number. When you factor, you break up your large number into things multiplied together. Okay, so how do we factor? Well, we said we're going to cover 3 techniques in this course, and this takes a lot of practice. So I highly recommend that you do all of the questions that I've posted for you, because it's not just about knowing what to do. There's a real skill. There's getting used to the numbers. There's sort of feeling out some questions and what you need to do, and that really just comes with practice. So please practice, practice, practice when it comes to factoring. A lot of students don't like it. I remember when I was in grade 10, factoring was something for some reason I struggled with at the time. And I always kind of dreaded factoring questions. And then I just kind of bared with it. I just worked as hard as I could. And then by the time I got to grade 11, I actually found it kind of easy. So it can kind of creep up on you that way. It can be hard, hard, hard. And then eventually when you work through it enough, it kind of just comes together. So please practice, especially if you're struggling with it. Please practice. So we're going to be coming up with 3 techniques. Okay, common factoring, difference of squares, and complex trinomial factoring. And to do this, we're going to use a method called decomposition. There are other methods to factor complex trinomials. I remember seeing one called Aussie rules or something at one point. I don't know, but we're going to use decomposition, which is the one that you've probably seen in your textbook. We're not going to cover simple trinomial or perfect square trinomial factoring. And the reason we're not going to do that is basically just time, because we're covering all of factoring in one lesson. It's a lot to ask to get you to learn 5 techniques. 3 techniques alone is hard enough. And we're going to focus on these 3 techniques because if you master these 3 techniques, you don't actually need these. These are nice little extras, but you can factor both of these types of situations using the complex trinomial method. I recommend that you learn these before you go to grade 11 because this method is slow and painful sometimes, and it can be really hard if you have a large perfect square trinomial to see how to do it this way. So if you know these techniques, it's going to be that much easier to factor. And it also just kind of helps, right? Math is a language, and the more things that you know how to say and do in a language, the more that language as a whole will make sense to you. So if you understand these techniques, it's going to help you in other areas in math that you don't even think about. Okay, so the ones we are going to cover. Common factoring. Always try to do this first. Whenever you have a factoring question, start here. Try and do common factoring. And often this strategy works when it looks like you can't do anything. So if you get some weird question that looks horrible, that's got like x cubed and 8 and like x and y and a whole bunch of things that you're like, I don't know what this is, it's likely that if you can factor it at all, remember not everything can be factored. If you can factor it at all, it's likely that you'll be using common factoring techniques. Okay, so let's look at a question where you'll do that. 18x to the 4 plus 9x cubed plus 3x. So we can factor this by common factoring. So we want to find a term that goes into each numbers. And we want to include the variables in that. So the minute you can see at least one x in everything, you know that you can divide all this by x. If you have x squared as your lowest term and you had, say, x3, x5 or something like that, then you can take out x squared. So whatever your lowest exponent is on x, as long as you have that or greater in every variable, you can take it out. So this is x to the 1. So the lowest x that we can take out is x to the 1. So we can take out x to the 1, but also notice you can divide each of these numbers by 3. So we'll take out 3x to the 1. So 18x to the 4 divided by 3x is equal to 6x cubed. And if you want to see if you did that right, because that can be a little confusing, distribute this back. 3 times 6 is 18. X times x cubed, remember we add the exponents, is x to the 4. Okay, so 18x to the 4 divided by 3x is 6x cubed. 9x cubed divided by 3x is going to be 3x squared. Again, distribute back and you can see that it works, right? 3x times 3x squared is 9x cubed. And 3x divided by 3x is just 1. So it's not 0, it's 1. Make sure you put that one in there. And then we factored that one as much as we can. So we leave it at that. All right, so if you want more examples where you're just doing common factoring, watch this video. There is some talk about greatest common factors and other things in this video that might help you or might not. But if you just want the examples, you can skip to 741 in this video. Okay, the hard one, decomposition. So this is the strategy that you can use when you have any factorable trinomial. So if you have a trinomial and you're able to factor it, you can use decomposition. So it works, as we said, for simple trinomials, for perfect square trinomials, or for complex trinomials, and that's why we're teaching this strategy. This is the go-to strategy. If you have a trinomial that's factorable, you can always do this. What do we mean by trinomial? We mean we have three terms, so 3x squared plus 4, that should be x, or x plus 1. That's a trinomial. You have three terms that are different, right? You can't add them or combine them, so that's a trinomial. As we said, decomposition is a slow process, so try to pick up on these other methods outside of this course to make your math a little bit easier. And also, when you're doing decomposition, you're kind of doing two methods. You're first doing decomposition, and then you're doing another method called grouping. Grouping is part of the decomposition method. So if you know how to do decomposition, then you also know this fourth method of grouping as well. But you want to be a bit careful, because grouping, when you do it outside of decomposition, when you're doing it on something that's maybe not a trinomial, the order of your numbers matters. When you're doing it with decomposition, it normally doesn't. All right, so let's look at an example. 4x squared plus 8x plus 3. We're going to factor this by decomposition. So the first thing you need to do is set up your problem. So you could do this in a chart like I've done here. This is mostly just to show you. If doing this chart helps, please by all means do it. But eventually you're probably going to get to the point where you can kind of do this in your head. Or at least write it down in a shorter form. So I've written this down in a shorter form in other questions. But basically, this is just showing you what you're supposed to be doing. So you take your leading coefficient, your number in front of the x with the biggest exponent. So that's going to be your 4 here. And you multiply that by the constant term, the term that doesn't have the x in it. So 4 times 3 is 12. Okay? So what you're doing then is you're going to decompose this 8 into two numbers. And those two numbers have to multiply to give you whatever this times this is. So you're looking to break 8x apart into two numbers that multiply to give you 12. And I would look at this part first, because you might know that there's an addition part as well. Do the multiplication part first, because you have a limited number of factors for 12. I've listed them here. There's an unlimited and literally infinite number of numbers that add to give you whatever it is that you're trying to get, in this case 8. Right? You could do 8 plus 0, 7 plus 1, 6 plus 2, 5 plus 3, and then you can add in negative numbers. So start with multiplication. What gives you 4 times 3? What gives you 12? What two numbers multiplied together gives you 12? So I've listed them here, positives and negatives. Okay, and the numbers should add to give you the middle term. Okay, so multiply to give you 4 times 3, and add to give you 8. So we can see that the only two numbers on this list that add to give you 8 are 6 and 2. So those are going to be what we use in our decomposition. We're going to break 8x apart into 6x plus 2x. Okay, so we do that here. So I take my 8x and I break it apart into 6x and 2x. I'm allowed to do that because I'm not changing the equation. This is still 8x, right? 6x plus 2x is still 8x. So now what you're going to do is you're going to be able to factor by grouping. Okay, when you have four terms like this, grouping is often used. And what you do in grouping is you group two of the numbers together and the other two numbers together, and you're going to factor them as if they're kind of separate problems on their own. So you're not going to factor the whole thing at once. You're going to break this into parts and factor the parts. So first we break this into parts. When you're doing grouping with decomposition, the order doesn't matter. So 4x squared could be grouped with 2x or 6x. Doesn't matter. What does matter, though, is you can't group 4x squared with 3. So don't do that. Right? Make sure that you're grouping an x with an x squared and an x with a constant term. But the order here doesn't matter. Okay? So we group the 4x squared with the 6x and the 2x and the 3. I can't factor anything out of the 2x and the 3, so I just leave it. 4x squared plus 6x, I can common factor out an x, and I can common factor out a 2. And you'll know if you've done this right, you've done it right if this bracket and this bracket are the same. So we can say that we've done this right. So now what I'm going to do is I'm going to common factor 2x plus 3 out of this part and this part. So if I divide 2x times 2x plus 3 by 2x plus 3, I'm left with 2x. And if I do the same here, I divide 2x plus 3 by itself, I'm left with 1. So remember, there is a 1 there. So I take out 2x plus 3 from both. Usually, we write that one first. Doesn't matter, really. You could write the other one first. But what I'm trying to show you here is that you're taking 2x plus 3 out, and you're left with 2x plus 1. Okay, so then there you go. That's fully factored. 2x plus 3 times 2x plus 1 is the factored version of what we have here. And you can see that if you re-expand. If you re-expand, you should get this. So you can see 2x times 2x is 4x squared. 3 times 1 is 3. 3 times 2x is 6. And 2x times 1 is 2. 6 plus 2 is 8. So it works out. Again, if you want to see some more examples, there's a video. The decomposition method in this video starts at 224 if you need a few more examples. Last one, difference of squares. So what's nice about this one is it's easy to see when you need to do it because you're just going to have two numbers and they subtract from one another. Okay, so actually just before I get to this, one more thing I want to mention here. Common mistake that I've seen. With the end of the decomposition here, what a lot of students will often do is they'll recognize that it's 2x plus 3 and 2x plus 1, but they'll put a plus sign there because there's a plus sign here. Don't do that, right? There's no plus sign there. You factored 2x plus 3 out of both of these. So if you factored something out, then what that means is you've divided. And so to get to the reverse, you have to multiply back in. So in other words, you're multiplying these two things together now. So this addition sign shouldn't be here. When you factor it out, the addition sign will disappear. Okay. So we are saying here, this is the easiest method to recognize because you have two numbers subtracted from each other. And the two numbers that you're subtracting are perfect squares. So a perfect square is something where if you take the square root, you get a nice number. You get a rational number, which is usually a whole number or it can be a fraction, but it's not something that goes on forever and is irrational. So 4 is a perfect square because if we take the square root, we get 2. Easy. 16 because we get 4. And this fraction is a perfect square because the top can be square root and you get 6, and the bottom square root you get 5. So these are nice, easy numbers. Right? 2 is not a perfect square because if you take the square root of 2, you actually get a number that goes on forever. By the way, if you kind of Google it, you can look it up on YouTube. If you really like this kind of stuff, there is a very simple way that you can prove that the square root of 2 is irrational. You can prove that it actually has no end, and not only that, but it has no pattern. And it's a proof that if you're kind of keen, you can probably understand even at this point in your math career. So yeah, you can actually prove that this number goes on forever, and you can prove that it doesn't have a pattern. You can prove it's irrational. Okay, so a squared minus b squared is equal to a plus b times a minus b. So this is the pattern that a difference of square will take when you factor it. So if you can recognize this part, then it's quite easy. So factor this expression, 25x squared minus 4y squared. So you can see that 25 is a perfect square and x squared is a perfect square. So this also has to be a perfect square. So you'll need something like x squared or x to the 4, something that you can have the x term multiply by itself to give you this. So for example, x squared is x times x, right? X to the 4 is x squared times x squared. You want something here that you can multiply two x terms together and it gives you this. Okay, so 25x squared is a perfect square. If we take the square root, we get 5x, right? 5x times 5x is 25x squared. So we know that the first number here is going to be 5x. 4y squared. Square root of 4 is 2. Square root of y squared is y. So our second part is 2y. So it'll be 5x and 2y. So we get 5x plus 2y and 5x minus 2y. So these problems, as I said, are typically not that bad. Just be careful. You might be able to common factor sometimes before you do the difference of squares. There are some more difficult problems where you might have to do difference of squares twice because you have a difference here. So if these are perfect squares, you might be able to do it again. That's not the case here. But it's generally pretty easy if you recognize it, the pattern. Just take the square root of this, the square root of that, and fill everything in. One more important thing to tell you about this, if this is a plus sign, you can't do this technique. So difference of squares must be a difference. It must be subtraction. If there's a plus, it can't be factored. So just leave it. Again, if you want more examples, this video will give you some. Okay, and the last thing to discuss about factoring is multiple techniques, because in some problems that are more complicated, you'll have to apply more than one factoring technique. So of the 3 techniques that we've covered, you might have to use something twice, or you might have to use one of the techniques and then something else. So an example would be if you're trying to factor this, 6x cubed plus 20x squared plus 16x. First thing to look for, remember, is common factoring. Every term has at least one x, so we can pull out an x. And these are all even numbers, so they can all be divided by 2. So we're going to pull out a 2x, and that gives us 3x squared from here, right? 6x cubed divided by 2x is 3x squared. 20x squared divided by 2x is 10x, and 16x divided by 2x is just 8. The x's cancel. Okay, so I factored this, but you have to ask yourself, can I further factor other terms there, or sorry, other numbers that we have? And the answer is yes, we can further factor this. And so this is a complex trinomial, so we'll have to use decomposition. So you could create your chart if you wanted to here. I'm going to do this more quickly instead. Remember, we want numbers that multiply to give you 3 times 8, the leading coefficient times the constant. So we want 2 numbers that multiply to give you 3 times 8, which is 24. Sorry, 2 numbers that multiply to give you 3 times 8, which is 24. And the middle term is 10, so we want those same 2 numbers to add to 10. So can you think of 2 numbers that multiply to give you 24 and add to give you 10? So if you go through the factors of 24, you'll find that the numbers are 6 and 4, right? 6 times 4 is 24. 6 plus 4 is 10. So we're going to break apart the 10x into 6x plus 4x. Okay, so once we've done that, we're now going to do grouping on this. So we're going to group 2 of these terms together. So I'm going to group the 3x squared plus the 6x. If you included the 4x instead of the 6x, you can still get the right answer. So I'm going to group those 2, and I'm going to group those 2. Out of the 3x squared and the 6x, I can factor out a 3x. 3x squared divided by 3x is x. 6x divided by 3x is 2. Easy. 4x plus 8, I can factor out a 4. 4x divided by 4 is x. 8 divided by 4 is 2. And we know we've done it right because these 2 are the same. So we're now in these square brackets going to factor out an x plus 2 from here and from here. So we factor out our x plus 2, and that leaves us with 3x plus 4. Once I've done that, I no longer need the square brackets because all these things are just multiplied, right? There's nothing that says I must multiply x plus 2 times 3x plus 4 first, and that's what the square brackets are telling me. It's saying do this first. Well, it doesn't matter. It's multiplication. The order doesn't matter. So I drop those, and I get the nicer looking final answer there. So that is this in factored form. And again, if you expanded all this, you should get back to this. Okay, so that's everything that I have to say about factoring. I've given you, as I said, a lot of questions to do. You'll notice that when you go onto the content page in Brightspace again, that there are multiple textbook sections because the textbook I have is divided into the different parts. And I've given up on trying to match up lessons with the textbook. Like I've said, the numbers are out of sync because sometimes I combine lessons or I skip others. So I'm just going to, from now on, just start calling the each lesson Unit 5 Lesson 1 and Unit 5 Lesson 2, and start forgetting about this stuff, the point 1 and point 2 and point 5, so that everything will line up with your textbook and it'll be a little bit easier to follow. Okay, that's it. Thank you.